Hi friends, today we are going to deal at another very interesting topic called partial differential equations, which is present in unit 3 of first B.tech in second semester. Talking about this unit has very short syllabus and it is very easy for the students to score more marks in this particular unit. In this slide, I am going to deal with introduction to PDE and its formation. So, what is meant by a partial differential equation and when it is said to be partial? See, it is also one type of differential equation in which it has some derivatives, and naturally any differential equation consists of two types of variables. One is the independent variable and the other one is the dependent variable. First of all, let us see these two wonderful examples. X square into dou z by dou x plus y square into dou z by dou y equal to z square. In this particular example 1, here z is the dependent variable and x and y are the independent variables. That means in the case of a partial differential equation, there will be two or more independent variables and only one dependent variables. Coming to the second example, dou square z by dou x square plus dou square z by dou y square is equal to 0. Here also the same case. Here z is the dependent variable which is present in the numerator part and x and y are the independent variables. Coming to the very basic concept of a partial differential equation, that is the order and the degree of a partial differential equation. The order of partial differential equation is nothing but you have to consider the highest derivative whatever is present in that particular equation. Coming to our example 1, so what is the highest derivative here? It is dou z by dou x and also dou z by dou y. So it is nothing but here the order is 1. And whenever you want to talk about the degree of this partial differential equation, it is nothing but the power of the highest order whatever you have considered in that particular equation. See here in example 1, by just seeing dou z by dou x and dou z by dou y, I am saying that its order is 1. Again I have to consider the power of it, it is nothing but 1. So for example 1, the order is 1 and degree is also 1. So it is wrongly spelled here, order is 2, here the order is 1 and degree is 1. In example 2, here the order is 2 and degree is 1. Whenever a partial differential equation is there, we have to solve it. So in the solution of a partial differential equation, what are the variables that exist there? See, it is just a function of independent variables only which satisfies the particular equation. Coming to the general solution of a partial differential equation, what does it contain? Normally it contains some arbitrary constants or arbitrary functions, or sometimes a combination of both arbitrary constants and arbitrary functions. And some notation is there regarding PDE. What is that notation? Whenever dou z by dou x is there, you represent it with the alphabet small p, dou z by dou y with q, dou square z by dou x square with r, dou square z by dou x dou y with s, dou square z by dou y square with t. After seeing these concepts, one doubt comes to you. Can we form a partial differential equation? Is it possible for us to form a partial differential equation? Yes, it is definitely possible for us, but we have to follow two simple methods. What are the two simple methods we have to follow? If any arbitrary constants are present there, we have to just remove them. If any arbitrary functions are there, we have to eliminate them. This is the simple practice you have to follow while forming a partial differential equation. Friends, now we will see what is or how to form a partial differential equation. Now, here I have considered one nice equation, that is z is equal to ax plus by plus a square plus b square. So, in this particular equation, what are the constants? First we have to check for the constants. What are they? A, B. Okay. And again, going through the question, what is being asked in the question? He has asked us to form the PDE, isn't it? To form a nice partial differential equation. And he has clearly stated that here the arbitrary constants are A and B. Please remove them so that you will get a equation. In any sort of question, first of all we should go through the question once or twice and make sure that what is given here and what we are required to do. So now consider z is equal to ax plus by plus a square plus b square. Here, what are the independent variables here? As stated before, x and y are the independent variables and z is the dependent variable. Now, I differentiate the given equation 1 with respect to x. So, what do I get here? On the left hand side, z is there. So, dou z by dou x is equal to small a is a constant. I set apart it. A into dou by dou x of x. What is dou by dou x of x? It is 1. So, a into 1 plus, again what is the constant in the second part? B. B into dou by dou x of y is 0, and we very well know that the partial differentiation of the constants a square and b square is also 0. So, what we are left with in the RHS part of the equation, after differentiating it with respect to x, we are left with dou z by dou x is equal to p. Equal to a. But we have already taken some nice notations for it. I represent dou z by dou x with p, that is a is nothing but p. Next, again differentiating the equation 1 with respect to y. What do we obtain? Dou z by dou y is equal to a into dou by dou y of x is 0, a into 0 is 0, plus b into dou by dou y of y. Dou by dou y of y is 1. So, we are left with only b, and again for a square and b square we get zeros. So, what do we obtain finally? Dou z by dou y equal to b. But what is the value of dou z by dou y? It is nothing but q. Therefore, q is equal to b. So, nicely we can eliminate the constants a and b, and in their respective places what we can write? P and q. So, what is our partial differential equation right now becomes? Z is equal to px plus qy plus p square plus q square. So, hence this is the required solution, or this is the way to form the partial differential equation in this particular equation by eliminating two arbitrary constants. So, before concluding this session, let me again rephrase all the concepts. What are the concepts we have dealt with so far? What is a PDE? How do we know about the order and degree of a PDE? How can we represent a PDE? What about the solution and general solution of a PDE? How we can form a PDE? Thank you, students.